Hi guys, welcome back to another YouTube video. I know it's been a while, just a bit over a year, but I thought I'd just create this video showing you a PID controller I've written for Kerbal Space Program in Python. Truth be told, I did want to do this in Java, but you know, KSP hasn't been updated in about 2 years. It's the final version. So KRPC hasn't been updated in 2 years, which is the mod I've used, as well as requiring a load of libraries, some of which are like 10 years old, so that was an issue. So yeah, I would have done this in Java and it would have a really nice GUI, but because I haven't used Python in a very long time, let alone use a GUI like Python, yeah. But anyway, let me just show you this quick little test here. We're going to set an altitude of 20 meters above the ground. Now this is from the center of mass of the vehicle, which is probably around here, to the surface, so like this launch pad here. So let's start off by doing this. I'll just run you through this little test and I'll show you how it actually works. Let's retract the gear here. As you can see, it's 20 meters above the ground, alright? Yeah, now what a really nice thing about this is that it's always going to try and maintain that 20 meters above the ground. So if I do this, it'll throttle up the engines according to, and then stabilize itself 20 meters above the ground. So that's right now really cool. Let's turn this around 180 degrees. And because of this fact, it actually handles like an airplane. It's really weird to say that. But this little rocket here that I've demonstrated here has a rapier. It's got some air brakes that act as sort of control surfaces like a Falcon 9. As well as an RCS system like the Falcon 9 as well. So let's try and... Now I'm going to just sort of like demonstrate here. It's really well controlled. I can feel my sort of thrust here. Like it is... like it's miraculous is probably the best way to put it. I think the biggest difficulty I'm having is keeping track of which way is forward on this vehicle. So here we go. Let's kill that speed. And there you go. So we can stop that now. We can. Oh god. Okay, that one. that could have gone worse. But let's quickly see how this program actually works. Let's just revert back to the launchpad. So let's have a look at how this works. So I'll start off by showing like the terminal. This shows you everything that the rocket is currently doing. So, well, I say currently doing, this is showing you everything, the stats from the PID controlling system I've got. So we've got the proportional, integral, and derivative values here, as well as the sum of all that. So what do I mean by that? I mean, so what is a PID controller? So a PID controller is proportional, integral, derivative, hence PID, as well as why I've got those on the screen. And it works by calculating first the error and then finding how much that error is, which is the proportional, the total amount of error, which is the integral, and the rate of change of the error, which is the derivative. And then it works by basically applying some constant to those, which are known as gains. But I like to call them constants because they're nice and easy. They're not really a constant because you change them, but yeah, and then basically sum them all up, and we see here that in the last moments of the rocket, you had basically full thrust trying to keep it up. But let's hop into the code. So I'll start off with actually showing you the PID class. So this is the class PID. We've got 6 variables here. We've got the constants I was telling you about, our gain values. As you can see here, they're all initialized to 0 at first. And then we've got the integral. That is literally the integral. We start off with 0 because obviously we have 0 error at first, and then the maximum and the minimum integral ranges. So I've got the maximum integral I can have is 1, and the lowest is -1. Sorry. And then we've got getters and setters. These are not used at all. I just went a bit ham. And then we got the constructor. So the constructor sets up all of our constants, all of our gains, as well as the maximum and minimum values for our integral. Anyway, hopping on, this is sort of like the maths of the PID controller here. As you can see, the first one here is the derivative. So we're literally just doing dy dt, or d dt in this case. And then we're multiplying it by a constant, as you see. Very similar thing with the integral. We're basically adding on the error multiplied by the change in time, or dt, and then we're multiplying it by the constant. And we're adding that onto the previous integral, so it's building up over time. And then we've got sort of our limits here for the integral, so we won't let it get above 1 or below 1. And the reason for that is, if this integral grows rapidly, it's going to take a really long time to also get low again, so you'll end up overshooting. So that's why we sort of have these sort of limits here. And then with our proportional, which is literally just the error multiplied by the constant or gain values, and then we just add them all up. But moving on to the actual class here, we're importing all our libraries, so KRPC, which is used to connect to Python, KSP, which is used to connect Python to KSP, rather. And that's this little module over here. KRPC is also the mod. And we're getting the version. And then we're setting up the vessel, as well as the flight information. And as you can see, we start off by setting SAS and RCS to true. Then after that, we set our desired altitude, in which case 20 meters above the ground, and that's 20 meters above the ground for the center of mass. So the center of mass will remain 20 meters above the ground, and you'll see that our altitude will change as we burn more fuel, because our center of mass will change in the rocket. Then we've got an anonymous function here, or a lambda function, and this is here that should just calculate, say we want to get to 1 kilometer in the air. Instead of using the PID controller, we would just set the engine to full power and shoot straight up in the air for a desired amount of time. And that's done here. And here we've got our PID object, and initiating it here. And then this is sort of like the main bit here. This is what you really want to be looking out for. So this bit here is just a continuation on from this lambda function, which is just calculating the acceleration, applying Newton's law of motion, F equals ma. I am saying a lot. And then literally just throttling up the engine and doing for that burn time, but I've turned it off because it's not really needed. And then finally, it's the logic loop. We've got it refreshing 30 times, so it'll update 30 times in a second. But just in case that sort of varies a bit, which it inevitably does, we do have an actual calculation for our delta time here. And as you can see, we are calculating the error, which is just the desired altitude, 20 meters, subtracted from our current one, which is not 20 meters. And then we just calculate the proportional, the integral, the derivative, setting the error to the previous one, so we can calculate our derivative the next turn, and then summing them all up. And then I've saturated the throttle a bit. Otherwise, well, the throttle on this is between 0 and 1, which will, as you can see, the sum here is 15, so it would shoot past that really quickly, and that is a saturated value as well. So, oh, that one hasn't been saturated. Sorry, the displayed one. But imagine if it was 0 to 1, it would be 15, so that's full throttle, and then you'd get this sort of pulsating throttle effect as it goes up and down, up and down. So to sort of refine it a bit more, I've divided it by 50. And then we go back to the loop, calculate our delta time again, multiply it by 1 billion. To get it into seconds rather than nanoseconds, and that's it. So the neat thing about this is that it works in any gravity too. So as you can see, I've got that up. Oh, not that one. Alt F12. And what I can do is I can hack the gravity, and I can make the gravity really low. And you'll see in a minute, it will just tone down the engine. It's actually turned it off. And it's gently igniting the engine just to try and get us about 20 meters above the ground. Now I haven't tuned this model perfectly, so expect there to be a bit, but if I reset the gravity, it'll fall back down, reignite that engine, and just try and balance us at 20 meters again. Same is true if we go up a bit. Now I need to watch out a bit. As you can see, it will hit the ground. Yeah, so we've not the most powerful engine in the world, so I do need just to turn it down a bit just so it can actually fly. But there you go. So it does work in different gravity conditions. I would need a more powerful engine to actually test it in high gravity. But that's sort of like a bit of proof. Now let's spin this thing around, shall we? And point it towards the VAB. Now this script is really cool. My end goal is I want to be able to launch a rocket from here and then land it on top of the VAB. But I mean, this thing has so many other uses. You know, you could use it as a cruise missile controller. as often cruise missiles need to maintain a set, especially like anti-ship missiles, like the what's the Falklands War? It escapes me, but that one would skim just above the surface of the ocean, and it would hit its target. So that would use a PID to maintain altitude. A similar setup could be done here with an aircraft, like an airplane. Yeah, but yeah. Alternatively, you could also use it to land rockets. You can make a more powerful PID per se, a more developed one that can also land at a very specific point. But this one's not very advanced. This is just a little altitude one. But yeah, I mean, if you like that, just to quickly say, I will definitely be making more videos now. My college is over. I'm free to make many more videos. But yeah, I mean, if you enjoyed this video, feel free to give it a thumbs up and a like. It means, you know, I know that people are actually watching these videos, and I will appreciate it a lot. But yeah, I mean, if you enjoyed it, then do thumbs up, leave a comment, and subscribe. I'll see you next time. Have a good one.